Afternoon, everyone. In the Laplace transform we discussed in the previous session. The last topic, the partial fraction method, quickly revise it. Right? The type 1, the factors are the linear and the distinct. Therefore, f of s is p by s plus a, s plus b. Then we can write like that. A upon one factor plus b upon the other factor. We discuss this problem based on that. Here, 1 upon s minus 1, s minus 2. Write using the partial fraction method. Then after take it LCM and we find this unknown values capital A and capital B. Okay. Therefore, we discussed in the previous session, when we find the value of the A, then this B part is the converting into the 0. And when we find out the value of the B, then A converting into the 0. Right? Using this concept, we find it this unknown values, apply in the equation number 1, and then apply the inverse Laplace transform. The second question on the same type, but here the 3 different factor and numerator is the not the constant. This is s plus 2. Okay. And the same concept apply over here. A upon one factor, B upon second factor, and C upon the third factor. Then take it the LCM. And then after one by one, find the unknown values, capital A, capital B, and capital C. Apply in the equation 1 and find the inverse Laplace transform. Okay. Yes. These are the questions in the homework for the practice. The question number 3 is the reference of the question number 1, and this is reference of the question number 2. Then we discuss the type number 2. Factors are the linear, but some factors are the repeated. And we can write into the partial fraction manner like that. Here one examples for your understanding. A upon one different factor, B upon the repeated factor power 1, and C upon the repeated factor power is 2. Okay. And this question, very simple. The same steps follows as per the type number 1. But here, when we take it the LCM, then we can't find directly these 3 values. First, we find out the 2 values because the 2 factors are here. Right? One factor is repeated. Therefore, 2 values we are getting. And for the third value, we put it the 0 or any other number, those who are not taking earlier. Okay. And after getting the 3 values, we are applying to the Laplace transform this and find the inverse Laplace. And this question is the similar, and you already done everyone yourself in the previous session. Now we discuss the type number 3. Wait 1 minute. Now we discuss the type number 3, one factor and one polynomial. Yes, Deepak. Factors are quadratic and distinct. F of S is equals P of S by S square plus AS plus B S square plus CS plus B. Okay. Therefore, we can write by partial fraction F of X is equal to AS plus B divided by S square plus AS plus B plus CS plus D divided by S square plus CS plus D. Okay, here the polynomial. Therefore, the numerator is the G. Please remember, capital AS plus B plus capital CS plus D. Note it down this one. Yes. Now the first example, this type. Find the inverse Laplace transform of, okay, 2s square minus 1. Yes, Rajkishore, 1 minute. S square plus 1, S square plus 4. Let's complete this slide. Yes, this is the previous slide, Manjit. Other previous slide, I revised the previous lecture session of type 1 and type 2. Right, this is the first slide of the slide. Now, see onto the denominator. These are the two factor, both are the polynomial, right? And both are the difference. Here s square is the common. Okay. Therefore, very easy method for this kind of question. As we assume f of s square minus 1 divided by s square plus 1 s square plus 4. Okay. Now we assume s square is equal to x. Therefore, our question is a little bit easy. Therefore, we generate the new function g of x 2x minus 1 divided by x plus 1, x plus 4. Right? When into the numerator and into the denominator. The same term is there, then we can assume it. If here s and here s square, then we can't assume it. Okay. Now, this one we can write using the partial fraction. By partial fraction. Therefore, g of x equal to a upon x plus 1 plus b upon x plus 4, because that is same like the type 1, right? X plus 1, x plus 4 into the x1. This is equation number 1, right? Now we take it the LCM, right here the numerator, 2x minus 1 a into x plus 4 plus b into x plus 1. Now find the value of a and b quickly. X equal to minus 1, that's why you are getting the capital A, and x equal to minus 4, that's why you are getting capital B. Yes, Saurav Kumar, very good. Saurav getting the value of the A. Apply an equation number 2. Writing over here the equation number 2 for your reference. 2x minus 1 ax plus 4 plus the book, very good, plus b x plus 1. Okay. X equal to x equal to minus 1. Minus 1 minus 1 equal to a minus 1 plus 4 plus b minus 1 plus 1 0. Therefore, minus 3 equal to 3a. Implies a equal to minus 1. There's Deepak and Saurabh. Very good. Now apply x equal to minus 4. 2 minus 4 minus 1 equal to a term is 0. Now remaining is b minus 4 plus 1. So minus 8 plus 1 equal to minus 3. Minus 9 equal to minus 3b. Therefore, b is equal to 3. This is equal to okay. Now apply this value in equation number 1. Therefore, g of x equal to minus 1 divided by x plus 1 plus 3 divided by x plus 1, value of a and b. Okay. Now, put it value of x. X equal to s square. Therefore, f of s equal to minus 1 by s square plus 1 plus 3 by s square plus 4. Right? And now apply the final step, inverse Laplace transform. It's easy. And for Laplace inverse Fs equal to minus Laplace inverse 1 by s square plus 1 plus 3 Laplace inverse 1 by s square plus 4. What is the answer? Yes, answer is yes, Kumar, very good. Yes, Pawan, Kevin. Yes, this is minus sin as it is sin t plus 3. This is 1 upon s square plus 2 square. Therefore, 1 by 2, therefore 3 by 2 sin 2. Yes, very good. This is our final answer. Okay, we will see this method. This is the type number 3. When both the factor into the denominator are the polynomial, and these are the different. Then we convert into the type number 1 with a very easy way. But the condition is into the denominator the s power and into the numerator both the factor the s power is the similar. Okay. 2s square minus 1, s square plus 1, s square plus 4. Now assume s square equal to x. Therefore, this is converting in this. Now by using the partial fraction method, we can separate this using the type number 1. Now taking the LCM, here we write the numerator, you know that on the left side. Then after find the value of A and value of B. Okay. Apply this value in G of X. And now this is converting for convert our example into the simplest way. Now we already found this A and B value. Now apply the value of the x. This is s square. Again substitute. Right? Therefore, our original question is this. Right? And now apply the inverse Laplace transform. Clear this method, everyone? Quickly write yes into the chat box. Okay, Roshan. Okay, now the similar one, the second question. Example number 2. Laplace inverse of s square plus a square s square plus b square. Apply the same steps in this question. This is fs equals s square plus a square s square plus b square. Now again here this s square power is the similar. Therefore, let s square equal to x. Therefore, g of x equal to x upon x plus a square x plus b square by partial fractions. Therefore, g of x equals a upon s square plus a square plus b upon s square plus b square. Okay. Now take the LCM. Okay, here my mistake, not s square but x. X. I'm putting the x value, but we apply x value at last. X. Now take the LCM. Therefore, x equals x plus b square plus b x plus a square. Now, one time apply x as a minus a square and one time x equal to minus b square. We are getting the values of a and b, capital A and B. X equal to minus a square. Times minus a square a minus a square plus b square. Therefore, a equals minus a square divided by b square minus a square. Minus taken common, therefore a square divided by a square minus b square. Okay. So finally, value of the a we are getting okay. Now x equal to minus b square. A square minus b square, right? Both the denominator is the same, therefore we take it this value as it is, minus b square. Yes, Deepak, very good. Divide by a square minus b square. Apply these values in equation number 1. Quickly note it down this. Apply these values in equation number 1. Therefore, g of x equal to value of the a square a square minus b square into 1 upon x plus a square. The value of the b is the negative, therefore minus b square, a square minus b square, 1 upon x plus b square. Now apply x equal to s square, right? Apply this value. Therefore, f of s a square minus b square, 1 s square plus a square minus b square, a square minus b square, 1 upon s square plus b square. Now apply inverse Laplace. F of t. This is constant term as it is. What is the inverse Laplace transform of this? 1 by a sine at minus b square, a square minus b square, and this is the similar one, but this is 1 by a sine at. One time b cancel, one time a cancel. Okay. Therefore, the final answer is D. 1 by a square minus b square take it power a sine at minus b sine at. This is our answer. Using this question, you can calculate any perfect square question like that. Laplace inverse of s square plus 4, s square plus 9. Right? And another one, you can put it over here, any perfect square value, right, for the practice. Here we take it the general value, a square, b square. You can apply any perfect square value. S square plus 1, S square plus 4. The same question. Clear, everyone? Again, discuss the same question 1 minute. This is the type number 3 when the denominator, 2 polynomial terms are there and both are the different. Okay, we're converting into the very easy way, but the condition is the s variable, s power in denominator and numerator is the same. And we put it s square equal to x. Therefore, this is converting into the type number 1, right? Simple factors, different factors. Therefore, a upon 1 factor, b upon other factor. And then we find it this value of capital A and capital B. And then after getting the values of capital A and capital B, again substitute the x value as a s square, right? जो हमने पहले assume किया था वो वापस हमें क्या करना है, apply करना है. Then after at the final step, apply the inverse Laplace transform. Clear, everyone? And then simplify, and this is the simplified version of our answer. And for the practice, you can do it these 2 questions. Clear, everyone? Okay. And what other technique? Without partial fraction, we can solve this question also. We will will discuss alter method, Laplace inverse s square divided by s square plus 4 s square plus 1. Okay. Now you can convert this using any other method. If you remember, then we discussed this kind of the question. If square is not, then s taken outside and subtract of this and divide by that. But if s square is there, then we have to apply the partial fraction method only, right? Because if you add this, that's why you are getting it to s square plus some number, and this are we are not multiply with, that is the whole thing. Now the type number 4. This is the combination of both the methods. Type number 4. One factor and one quadratic term. Therefore, f of s is equals p of s plus e, s square plus bs plus c by partial fraction f of s. This is the single factor, therefore a upon this single factor, right? Using the type number. Using type number 3, this is the polynomial, therefore ps plus. Right, this is the partial fraction. Okay, note it down, this type number 4, then we will discuss one question. And the civil engineering student, your lab session tomorrow morning 8:50, right? 8:50 a.m. Right? Why the timing it 8:50? Because you're joining in time and I will start at the 9 o'clock sharp. Clear everyone, civil students? Right? We will start the meeting at 8:50 a.m. tomorrow's morning, right? And start the lecture at sharp 9 o'clock. Okay? One question. This combination from Laplace inverse 5s plus 3 s minus 1 s square plus 2s plus 5. First write the fs. 5s plus 3. Here one factor and one polynomial. Therefore, by partial fraction, And on tomorrow lab session, and then after 10:30, one lecture session, and madam will take my lecture on Wednesday. Right? Madam will give my lecture on Wednesday. Therefore, on probably on tomorrow, Laplace transform is the right. Then after next week, we will start the another new chapter. Fast. And this whole Laplace transform and inverse Laplace transform in your second midterm exam, therefore be prepared for that and start the practice of all that. Right? Question number 1. Take the LCM 5s plus 3, write numerator a into s square plus 2s plus 5 plus ps plus c s minus. Okay, Karnavi, Kunal, any other students Saurav, tell me how can we find it? Okay, which number you want to write something onto the slide? And you can also share your whiteboard and start solving this question. No problem. Yes. Yes, Manjeet. Yes, Manjeet. Yes, anyone. Tell me how can we find it this? Karnavi, Priyanka, Kinjal, Kunal, Saurav Kumar, Deepak. Yes, Karnavi. Writing over here equation number 2. Okay. Yes, Deepak, unmute yourself. Yes, s equal to 1. It's correct. A s square plus 2s plus 5 plus 1 b s plus c s minus 1. Right? Equation number 2. Repeat it again. Now apply s equal to 1 first. Therefore, this term is 0. We are getting the value of it. 5 into 1 plus 3 equal to a 1 plus 2 plus 5. Therefore, 8 equal to 8. So a equal to 1. Okay. Now, for this equation number 2, we can write, open this bracket on this side. 5s plus 3 equal to a s square plus 2as plus 5a plus bs square minus b plus cs minus c. Okay. Now s square term, a plus b, s term, 2a s square is a plus b, 2as bs square minus bs. Yes, it's here. Minus b plus. The constant one is 5a plus 5a minus c. And the left hand side, 0, s square term is not here. 5 into s plus 3. Okay. Now compare coefficients of s square, s, and constant. both sides. क्योंकि हमें यहाँ पे एक ही वैल्यू मिल रही है, बाकी दो वैल्यू हम कैसे फाइंड कर सकते हैं? तो हमें क्या करना होगा? कोएफिशिएंट कंपेयर करना होगा। तो कोएफिशिएंट कंपेयर करने के लिए हमें ये जो ब्रैकेट है वो ओपन करना है और बाद में कैसे लिखना है? एस स्क्वायर के जो भी मल्टीपल है वो एक ब्रैकेट में, एस का मल्टीपल अनदर ब्रैकेट में और कांस्टेंट टर्म अनदर ब्रैकेट में। तो अब हम इजीली उसको कंपेयर कर सकते हैं। ए प्लस बी किससे कंपेयर होगा? 0 से। अब मैं दूसरा कलर लेती हूँ यहाँ पे। यस, अब ये जो एस की टर्म है ये किसके साथ कंपेयर हो जाएगी? उसका कोएफिशिएंट, तो बी के साथ। और ये जो कांस्टेंट है वो कहाँ पे कंपेयर होगी? 3 के साथ। हमें 3 इक्वेशंस मिलेंगे, ठीक है। Therefore, a plus b equal to 0. अब a plus b equal to 0, right? But a equal to, we are already getting the value of a is the 1. Therefore, b is equal to 1 plus b 0. Therefore, b equal to -1. Okay. Now in the previous slide, now we have to find C, and A and C combination is here. Therefore, we compare this. Constant 3 equal to 5A minus C, but A equal to 1. 3 equal to 5 into 1 minus C. Therefore, C equal to 5 minus 3 is a 2. Therefore, C equal to. Okay, everyone? Apply.
Ma'am, previous slide, please.
Yes, 1 minute in this one. This is coefficient of s square, and this is the constant. Nitish Kumar, if done this slide, then write yes into the chat box.
Done, ma'am.
Okay. Apply this in equation number 1. Therefore, f of s, a is a 1, divide by s minus 1, and value of the b is the -1, therefore minus s, value of the c is the 2. Divide by s square plus 2s plus 5. Okay. Now first term is easily we can solve the inverse Laplace. But the second term, we have to change this, right? First minus sign. First we change this denominator. 5 means 4 and 1. First shifting theorem, if you remember, this kind of the question we done. S square plus 2s plus 1 plus 4. And here we change it s plus 1 minus 3. Okay, minus 3 plus 1, because we apply here minus sign, this is minus s, and when we put it minus, therefore this sign is to change, -2, therefore -3 plus 1. S plus 1 minus 3 by s plus 1 whole square plus 2 square. This is our fs. Apply inverse Laplace. Laplace inverse Fs. Here we get it directly, e raised to t. Here s plus 1. Therefore, e raised to minus 2. What is the remaining term? S minus 3, s square plus 2. Complete this, and the final touch of this question. Done, everyone? Anyone remaining, then raise your hand. Okay. Therefore, Laplace inverse Fs e raised to t minus e raised to minus t into the bracket, separate the term s by s square plus 4 or 2 square plus 3, yes, plus 3 Laplace inverse 1 by s square plus 4. E power t minus e raised to minus t cos 2t plus 3 by 2 sine 2t. This is our answer. Yes. We discuss this question, then after session, this is little bit bigger. That's why this is the last step, combination of both the term. Right? In the first step we can find it direct values. In the second type, two values we can find it direct. And for the third value, we have to put it either 0 or apply the number that is not utilized early. In the third, we put it s square equal to x and converting into the type number 1. And in the fourth type, this is the combination of first type and the third type. Right? F of s, and write into the partial fraction, take it the LCM. Now after taking LCM, one value we get it directly, and for the other values we open this bracket, equation number 2. Then how to arrange these terms? S square coefficient, S coefficient and constant term into the separate brackets. And then after compare the both the sides equations, right? And we get it the value of A. Therefore, we utilize this S square coefficient equation and constant term equation. Therefore, we are getting the value of B and C. Okay. Apply this, and here one new term in this question into the denominator, that is not the perfect square, therefore converting it. So many questions we solved in the inverse Laplace transform using the first shifting, right? The same thing we apply over here. S square plus 2s plus 1 plus 4. Here change this term, apply this, and then after apply the inverse Laplace transform. Yes, this is the final answer. Now, any doubt regarding these 4 types, then quickly raise your hand. 4 types of the partial fraction method. Check it in your notebook, all the questions, right? If you have any doubt in any question, then please raise your hand in any type. If you have no doubt, then quickly write yes into the chat box or done into the chat box. Quickly. No doubt in any type, then quickly write yes or done into the chat box. Quickly. Write your response into the chat box, everyone. Okay, thank you very much, everyone. Have a good day. Now revise all the Laplace transform, right? And on tomorrow's lecture session, we make a summarize all the chapter, right? In one session, right? And that's why one notes on the Laplace transform in one session. Be present and make it the notes in this session, right? We will meet. Thank you very much, everyone.